Okay, you little math lovers, here's the second video in the dividing fractions series. There are 3 videos total. This is the second one. Let's start off by looking at this problem, 6 divided by 2/3. We'll begin by visually representing 6. And now let's carve this up into thirds. There we go. Now, what the statement 6 divided by 2/3 means is how many 2/3 are there in 6. So here we have our 6 carved up into thirds. Here's 1 2/3, here's 2, here's 3, here's 4, here's 5, and here's 6, right? Each of those is 2/3. And then we got to go down here. Here's another one, here's another one, and here's another one. So how many is that total? We got 1, 2, 3, 4, 5, 6, 7, 8, 9. And yes, I am aware that those look like weird little faces. So the 6 divided by 2/3, how many groups of 2/3 are there in 6? There are 9. As mathematicians, of course, we're always on the lookout for patterns. So here's a pattern that I noticed here. If we multiplied, let's represent 6 as 6 over 1. If we multiplied by the reciprocal of this fraction here, the reciprocal is when we just put the denominator in the numerator and the numerator in the denominator. It's also called the multiplicative inverse. I'll write that down for you later. But if we multiply by the reciprocal, we get 6 times 3 is 18, over 1 times 2 is 2, and of course 18 divided by 2 is 9. So that's an interesting thing. We're going to look and see if we can find a pattern with regards to that. Looking quickly at this problem, 7 divided by 4, I want to show how we can represent a division problem that has a remainder. I want to show how we can represent that visually. Here we have 7. So how many groups of 4 can we divide it into? Well, one group of 4, and then oops, we can't quite divide it anymore, so we got to kind of add an imaginary line here. That would be 4, but we only have 3 out of that 4, right? 1, 2, 3 out of 4. So our answer is 1 whole and 3 out of the 4 that it would take. Let's continue that method onto a division problem that involves a whole number being divided by a fraction with a remainder. So here are our 5. We're trying to wonder how many groups of 3/4 are there contained in this 5. So here is our 5 carved up into fourths, and we're wondering how many groups of 3/4 are there. Here's 3/4 here, there's 3/4, there's 3/4, there's 3/4, there's 3, and there's 3, and we have 2 left over. For us to get another 3/4, we would need another box up here. One more fourth. But we only have 2 of them. We have 1, 2 out of the 3. So our answer is 1, 2, 3, 4, 5, 6, and 2/3. 6 and 2/3. Again, as a mathematician, I'm always on the hunt for patterns. So instead of doing this division, I'm looking at multiplying by the reciprocal of this again. And we'll see if this works. 5 times 4 is 20, over 1 times 3, which is 3. Is 20/3 the same as 6 and 2/3? Think about that for a sec. Yes, it is. That also equals 6 and 2/3. So we see again, multiplying by the reciprocal has been the same as dividing. And as good mathematicians who are always hunting for patterns, when we find them, we want to discuss them in terms of a rule that we can use for future problems as well. And here we have it. I want you to write this down. Dividing by a fraction is the same as multiplying by the fraction's reciprocal. Or, to get you guys to start to use the terms you're going to learn in algebra, the multiplicative inverse. So what is the reciprocal of the multiplicative inverse? It's the same fraction, but with the numerator and the denominator switched around. This is probably the method that you learned in 5th grade. Thanks very much, everyone. Take care, and we'll see you in math class.